So here we are, Unit 3, Lesson 11, Application of Quadratic Functions. So I cannot show you every single word problem because an application is a word problem of a quadratic function, but I can give you 3 basic things to look for in each word problem, and then to connect to what we've been doing with quadratic equations and quadratic functions. The first thing to look for is in the word problem talking about the maximum or the minimum. Other words that mean maximum or minimum would be your highest or your lowest values. So it could be the highest that somebody jumps or the lowest value of a stock, something that's the maximum or minimum. If a word problem talks about the maximum or the minimum, they're talking about the y value of the vertex. And you know that you can get the y value from the vertex from the equation when it's in vertex form, y equals bracket a minus p squared plus q, or you can look at the graph and read it right off the graph, see where the vertex is on the graph. So if a word problem talks about a maximum or a minimum, a high or low value, you're looking for the y value of the vertex. Second thing to look for, if a word problem talks about an initial position or an initial value or a starting point, they want you to find the y-intercept, the place where it crosses the y-axis. You can literally look at the graph if you have a graph and see where it crosses the y-axis, or if you don't have a graph, put 0 in for x and calculate the y number. So maximum or minimum is the y number from the vertex. Initial position or initial point is the y-intercept. Put 0 in and calculate how much it is, or look at the graph. Third thing, the points on the parabola where the y value is 0. When you're talking about a word problem, they're referring to something hitting the ground, like a ball or a rocket, or a business that's breaking even. These are the x-intercepts of the parabola. So you can literally look at the graph and see where it crosses the x-axis. Or you can calculate it by setting y equal to 0 and using the quadratic formula to solve for x. Those are the 3 key things to look for in a word problem. So let's look at an example together. A model rocket is launched from the roof of a building. The flight path of the rocket through the air is modeled by the equation h equals a -5 bracket t minus 3 bracket squared plus 55, where h is the height of the rocket in meters and t is the time since it was launched in seconds. How high is the building? So we have to interpret the question. It is not explicitly stated in the question how high the building is. But the question does say the rocket is launched from the roof of the building. If it's launched from the roof of the building, that is the starting point. And the starting point is another word for initial value. We talked about previously the initial value. Whoops. Wait, I gotta set my pen down. Our 3 key things. The initial value or the starting point is the y-intercept. So if I don't have a graph, I'm going to put 0 in for x and solve for y. That means I'm going to put 0 in for t and solve for my h. I need to grab my calculator and we'll figure that out. So when we put 0 in, that tells us our initial or our starting point. We know the height of the building is the starting point because it says the rocket is launched from the roof. So it's starting from the roof. A starting point comes from putting 0 in for x. And if you look at our equation is usually written y equals blah, 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 x. So our t is like our x. All right, I found my calculator. See if I can get an answer here. We have 5 plus 55, 10 meters. So we've got 10 for an answer. That tells us the building is 10 meters high. What is the maximum height that the rocket will reach? There's that term, maximum. We talked about it previously. The maximum refers to the y number of the vertex. If we don't have a graph, we want to make sure our equation is in vertex form, and it is. And we can read our vertex right from our equation. Our vertex will be 3 and 55. So the y number of the vertex is 55. So the maximum height of the rocket is 55 meters. How high will the rocket be 2 seconds after launch? So this doesn't apply to any of the 3 things I talked about. This is some common sense. 2 seconds after launch. 2 seconds is our time. All we have to do is fill in the value for our time into our equation. That means take out the t and put in 2. So if I take out the t and put in 2, I have 2 minus 3 squared plus 55, which will give me 1, negative 5, which will give me 2 take away 3 is negative 1. Negative 1 squared is 1 times negative 5 is negative 5 plus 55 would be 50. So after 2 seconds after it is launched, the rocket is 50 meters high. And last one, when will the rocket hit the ground? When will the rocket hit the ground? There's the last one I was talking about. When it hits the ground is when the height is 0. That is your x-intercepts. When it hits the ground, that's when the height is 0. It's no longer in the air. So if the height is 0, I'm going to take out the h and put in 0 and solve that. So if I put 0 in for that, I have got negative 5 x minus 3 squared plus 55 equals 0. Now I'm going to have to do a bit of work to solve this. In order to solve it, I need to have it in a form that I can either factor or use the quadratic formula. Which is negative b plus or minus the square root b squared minus 4ac over 2a. In order to do either one of those, the equation has to be in standard form. Right now it's in vertex form. To put it into standard form, I need to expand and collect my like terms. So I need to remove the brackets and collect like terms. To put in standard form. So if I'm going to remove my brackets, I'm going to have x minus 3 times x minus 3, and I'm going to have to do FOIL. x squared minus 6x plus 9. And then multiply everything by -5. And I've got -5x squared plus 30x plus 10 equals 0. I might actually be able to factor this. I'm going to start by taking a common factor out. I'm going to divide them all by -5. And once I do that, I've got a simple trinomial. If I want to try and factor that simple trinomial, I'm going to look for something that multiplies to -2 and adds up to -6. And I know that there's nothing that's going to multiply to -2 and add up to -6. So I need to use my quadratic formula. My A value is 1, my B value is -6, and my C value is -2. Oops. I just realized I changed all the T's to X's. The T magically changed to an X. You guys got the idea. The X is like my T in the equation. All right, we'll see who's listening and can pay attention and see what I did wrong. So I'm back to this. I'm going to use my quadratic formula. So -b, -6 would be +6, plus or minus the square root of b squared, -6 squared, minus 4 times a times c, over 2 times a. So we have 6 plus or minus the square root of 36 plus 8, 44 over 2. So I'm going to calculate that. So I'm going to do plus the square root of 44 and divide by 2. And I'm going to do minus the square root of 44 and divide by 2. So what have we got? So we have got 44 square root plus 6 divided by 2 equals about 6.3. And if I do 6 minus square root of 44 divided by 2 would be about -0.3. So way back at the beginning, we were talking about when. So we're looking for a time. I look at my answers. One of these should not make sense. One of these things does not belong. It is the negative, because you can't have a negative time. So since you can't have a negative time, there's only one answer. Therefore, when does a rocket hit the ground? After about 6.3 seconds, the rocket will hit the ground. So I can't show you every possible thing you're going to see in a word problem. You have a handout, a whole page of word problems to do. What do you need to remember when you tackle those word problems? Is it a maximum or minimum? If it is, look for the vertex. That's the y number of the vertex. Is it an initial position or initial value or starting point? If it is, it's the y-intercept. Put 0 in for x and solve for y. Is it asking you for where something hits the ground or it's breaking even? Then you set the whole equation equal to 0 and factor or use the quadratic equation or quadratic formula to solve. So you gotta look for those 3 key terms in each word problem, and that should get you through them. Good luck.